Let's look at question 6. It says a particle moves in a straight line. Its velocity in meters per second at time t seconds is given by v equals t squared minus 4, all being cubed from 0 to 3. Find the velocity of the particle when t equals 1. So I'm just subbing 1 right into the velocity curve, and it's going to look just like this. So 1 squared is going to be 1, minus 4 is going to be negative 3. Negative 3 cubed is going to equal negative 27 meters per second. Okay. Find the value of t for which the particle is at rest. We know that the particle is at rest when v of t equals 0. So let's go ahead and take v of t and set it equal to 0. T equals plus or minus 2. I'm going to go ahead and reject the negative 2 because the interval is from 0 to 3. Okay, so I just have t equals 2. Find the total distance the particle travels during the first 3 seconds. Okay, so this is a calculator question. Total distance traveled. I'm going to integrate the absolute value of the velocity curve from 0 to 3. Okay. I get 86.257, which equals 86.3 meters. And then it says, show that the acceleration of the particle is given by a equals, okay, so we need to integrate, we have to take the derivative of the velocity curve and match it to the structure that's right here. So let's go ahead and take the derivative. We're going to start with t squared minus 4 cubed. So I see that this is going to be a chain rule, right? I have a function within a function. The inner function is t squared minus 4. The outer function is 3. So what I'm going to do is I'm going to take the 3, drop it in the front. I'm going to reduce the power by 1. Don't touch the insides. And I'm going to multiply by 2t. So if I simplify that, I'm going to get the 2 times 3 out front, which gives me that 6t that this problem has. And I'm all set. Now it says find all possible values of t for which the velocity and acceleration are both positive. So whenever we're comparing the signs of the velocity and acceleration, it's very helpful to do a number line. So we are both positive. Sorry, this part got cut off. I didn't see it until now. Or both negative. Okay, good to go. So this is from 0 to 3. This is the velocity curve. This is also from 0 to 3, except now this is the acceleration curve. Okay, so now I'm looking for the 0 of the velocity function, which I think we found above actually, which is 2. And to the left of 2, the graph is negative because all of its y outputs are below the x-axis, and then to the right, it is positive. Now let's check the derivative function. I could just type it in, but also I could just do it this way. And it looks like right at 2, he has a x-intercept, but he's positive on either side of 2. So I'm just going to put positive on both sides. So it looks like we have the same sign for this interval right here from 2 to 3. So we would say velocity and acceleration have the same sign from 2 up to and including 3.